बच्चों, नमस्कार। कबीर केमिस्ट्री क्लासेस में आज हम फिजिकल केमिस्ट्री की शुरुआत करेंगे, क्लास 12 की फिजिकल केमिस्ट्री। और इसमें हमारा सबसे पहला जो चैप्टर है वो है चैप्टर नंबर 1, द सॉलिड स्टेट। ये पार्ट 1 है इस वीडियो का, और भी बहुत सारे पार्ट्स में मैं इस चैप्टर को कंप्लीट करूँगा। तो आप पार्ट बाय पार्ट टॉपिक को समझते जाइएगा। बट द मोस्ट इम्पोर्टेंट क्वेश्चन इज दैट इफ़ यू रियली वांट टू स्टडी, if you are very sincere for your study, so then you must be ready with your copy and pen. Be ready with your copy and pen. और अगर इस चैनल पर आप पहली बार आए हैं तो प्लीज़ इस चैनल को लाइक, सब्सक्राइब और शेयर करें। बट वो करने से पहले कोशिश करना कि आप कॉन्सेप्ट्स को समझ लें। अगर आपको अच्छा लगे तो आप शेयर कर सकते हैं। तो कबीर केमिस्ट्री क्लासेस में आज हम चैप्टर 1 सॉलिड स्टेट स्टार्ट कर रहे हैं, पार्ट 1। जैसा कि नाम इंडिकेट कर रहा है, द सॉलिड स्टेट। सो व्हाट सॉलिड स्टेट? इट इज द स्टेट ऑफ मैटर, you know very well. And what is matter? Matter, anything which has mass and occupy the space, that is called matter. And you know very well the matter basically has 3 states. One is solid, another one is liquid, and then gas. Liquid and gas we have already studied in class 11th. Here we are going to study the solid state of the matter. So it is basically a state, and those substances which exhibit in that state are known as solids. Okay? तो यहाँ पर आपको मैटर से रिलेटेड एक और कॉन्सेप्ट को ध्यान में रखना है, दैट इज कॉल्ड सीपी। सीपी मीन्स कॉन्स्टिट्यूएंट पार्टिकल, कॉन्स्टिट्यूएंट पार्टिकल्स। तो कॉन्स्टिट्यूएंट पार्टिकल्स मीन्स बाय विच द मैटर हैज बीन मेड अप ऑफ। दीज कॉन्स्टिट्यूएंट पार्टिकल्स मे बी of 3 kind. One, maybe it is atom or molecule or maybe ion. So depending upon the nature of the particle, we have different kind of matters. So solid state is a state of matter, and the substance which exhibit this state are known as solid. So what is the main characteristics of the solid state? What is the main characteristic of the solid state? The main characteristic of the solid state lies in the force which exists in it. The force, that is intermolecular force, which is very strong in the solid state. Means the substance which exhibit solid state have the strong intermolecular forces. ये इंटरमोलिकुलर फोर्स स्ट्रॉन्ग होने की वजह से कॉन्स्टिट्यूएंट पार्टिकल्स आर वेरी क्लोज्ड टू ईच अदर, आर वेरी क्लोज टू ईच अदर, वेरी क्लोज टू ईच अदर. When the particles are very close to each other like this, then these particles will have the rigid shape, they will have the definite mass, they will have the definite volume, and they will have the definite shape just because of the strong intermolecular forces. But let me explain you what does mean by intermolecular force. Intermolecular force means the force between the particles. Force between the particles. There are different kinds of forces that we had studied in class 11th, like dispersion forces, dipole-dipole interaction, dipole-induced dipole force. All those are known as intermolecular forces. So in the case of the solid state, the intermolecular forces are very strong, by which the constituent particles are very close to each other. They are not free to move. Their intermolecular distance is very short. Their intermolecular force distance is very short. That's why, because of that, their constituent particles like atoms, molecules or ions have the fixed position. Why constituent particles have the fixed position? Because of the strong intermolecular forces. And because of this strong intermolecular forces, they can only oscillate about their mean positions, which make them rigid and incompressible. So all these are the consequences of this strong intermolecular force. So this is the reason behind all these kind of the consequences. And nowadays you know very well that in the board exam the assertion region types question comes in very heavy marks, na? So here we can also understand the assertion region question. So reason is what? The intermolecular forces are very strong. Because of that we have different kinds of assertion. Assertion is nothing but the claiming of the right facts or the wrong facts. Okay, that is the claiming. So if I am saying that solid particles or the solid state, they have definite mass, definite volume, definite shape. Why they have definite shape? Because particles are at their position. Why particles are at their position? Why they cannot move? Because of the strong intermolecular forces. So the reason behind it is the intermolecular forces. तो ध्यान क्या रखना है आपको कि जो मैटर है आप इसको इस तरीके से समझ सकते हैं कि एक मैटर है, उसके 3 बच्चे हैं, ठीक है। बड़े लड़के का नाम है सॉलिड, उसके छोटे लड़के का नाम है गैस, और उनकी एक प्यारी सी बहन है जिसका नाम है गैस, ठीक है। छोटी है तो वो बहुत चंचल है और उसके अंदर जो कॉन्स्टिट्यूएंट पार्टिकल्स है वो बस घूमते ही फिरते रहते हैं, नज़दीक बैठते ही नहीं है। और सॉलिड बीइंग द एल्डेस्ट वन, वो सबसे बड़ा है तो वो शांत रहता है, पार्टिकल बिल्कुल नज़दीक बैठे रहते हैं और ज़्यादा परेशानी क्रिएट नहीं करता है। तो कॉन्स्टिट्यूएंट पार्टिकल्स आर वेरी क्लोज टू ईच अदर इन द केस ऑफ द सॉलिड, and in the case of the liquid the particles are not so much close as in the case of the solid, but they are enough closed as if we compare it with the gaseous state. And in the gaseous state the particles are very far from each other. If we talk about the gaseous particle, we can say if one particle is in Calcutta, another particle is in Delhi, we can say that means the forces between these particles are negligible in the case of the gaseous state. So here up to now what we have studied that the solid state have different general characteristics, and the basic reason behind all these kinds of the general characteristics is the intermolecular forces. I think up to now everyone has understood. Whatever I have been teaching you, please note down in your copy. Okay, just take it as your offline class, take it as your consider that the teacher is teaching you in front of you, है ना। तो आपको चीज़ें बिल्कुल प्रॉपरली ऐसे ही नोट करते हुए चलना है। तो आपको यहाँ पर असर्शन और रीज़न का भी कॉन्सेप्ट समझ में आया होगा कि किस तरीके से रीज़न जो है वो डिफरेंट कॉन्सिक्वेंसेज जनरेट करता है। अब हम अगले टॉपिक की तरफ बढ़ें उससे पहले मैं आपको बताना चाहूँगा कि जो ये सॉलिड है, ये सॉलिड अलग अलग कैटेगरी में क्लासीफाई किया जा सकता है। वी कैन क्लासीफाई द सॉलिड इन डिफरेंट कैटेगरी, है ना। जो सॉलिड सब्सटेंस हैं, इन सॉलिड सब्सटेंस को हम अलग अलग कैटेगरी में डिफाइन कर सकते हैं। तो अभी हम जिस कैटेगरी में डिफाइन करेंगे वो होगा बेस्ड ऑन द अरेंजमेंट ऑफ द कॉन्स्टिट्यूएंट पार्टिकल्स। कॉन्स्टिट्यूएंट पार्टिकल्स की अरेंजमेंट के बिहाफ पर मैं सॉलिड को डिफाइन करने वाला हूँ या सॉलिड को क्लासीफाई करने वाला हूँ। तो पहला क्लासिफिकेशन जो हम पढ़ने जा रहे हैं सॉलिड्स का वो है कॉन्स्टिट्यूएंट पार्टिकल की अरेंजमेंट के बिहाफ पर। और अरेंजमेंट के बिहाफ पर जब हम सॉलिड्स की बात करते हैं तो सॉलिड 2 तरीके के होते हैं। वन इज नॉन एज द अमॉर्फस सॉलिड एंड अनदर वन इज नॉन एज द क्रिस्टलाइन सॉलिड। अमॉर्फस सॉलिड और क्रिस्टलाइन सॉलिड को हम किस तरीके से समझेंगे, ये कुछ प्रॉपर्टीज हैं, ये डायरेक्टली आई हैव टेकन दिस फ्रॉम द एनसीईआरटी सो दैट यू कैन अंडरस्टैंड एंड यू कैन ट्रस्ट ऑन द ऑथेंटिसिटी ऑफ द कंटेंट। ओके, तो ध्यान रहे कि मैं जो भी कंटेंट आपको पढ़ाने वाला हूँ टोटली एनसीईआरटी बेस्ड होगा। बच्चे बहुत कंफ्यूज रहते हैं कि नहीं हमें तो जब तक हम एबीसी नहीं पढ़ेंगे हम साइंटिस्ट नहीं बनेंगे, जब तक हम प्रदीप नहीं पढ़ लेंगे तब तक तो हमें केमिस्ट्री आएगी ही नहीं, और इसी चक्कर में वो एनसीईआरटी पढ़ना बंद कर देते हैं। सो एनसीईआरटी इज़ द मोस्ट इम्पोर्टेंट बुक फॉर एनी एग्जाम रिलेटेड टू योर स्टडी। तो अमॉर्फस सॉलिड और क्रिस्टलाइन सॉलिड को कैसे डिफाइन करते हैं, देखो आप बहुत साधारण भाषा में समझें तो ये समझ लो कि क्रिस्टलाइन सॉलिड वो बच्चा है जो नहा धोकर एकदम साफ सुंदर रहता है, उसके सारी चीज़ें ऑर्डरली अरेंज होती हैं। अमॉर्फस सॉलिड वो है आलसी लड़का है, चीज़ें इधर उधर फैली हुई हैं, इरेगुलर शेप है और बस ऐसे ही काम चल रहा है। क्रिस्टलाइन सॉलिड एकदम स्मूथ सरफेस है, बाल एकदम अच्छे से बहा होकर एकदम बहुत सुंदर तरीके से बैठा रहता है। अमॉर्फस सॉलिड है बस क्लास में गए पढ़ लिया नहीं तो सो रहे हैं आराम से, ठीक है। अब केमिस्ट्री लैंग्वेज में भी समझ लेते हैं कि क्रिस्टलाइन सॉलिड और अमोर्फस सॉलिड कैसे हैं? देखो, एक बात बहुत खास जो एनसीईआरटी में डिफाइन कर रखी है वो देखो, प्रॉपर्टी के बिहाफ पर डिफाइन कर रखा है। प्रॉपर्टी एक तरफ मेंशन है और फिर यहाँ पर क्रिस्टलाइन सॉलिड और अमोर्फस सॉलिड को इंडिकेट कर दिया है। तो चलिए समझते हैं। सबसे पहली प्रॉपर्टी जो ली है वो है शेप। तो क्रिस्टलाइन सॉलिड की अगर हम बात करें तो दे हैव डेफिनेट characteristic geometrical shape. They have the specific geometrical shape, crystalline solid, but amorphous solids does not have the geometrical shape. They have irregular shapes. Okay, now we are talking about the melting point. If we are talking about the melting point, the crystalline solid have the sharp and characteristics temperature. They have the sharp melting point. Why they have the sharp melting point? The answer lies in the next property. Answer lies in the next property. So this is nothing but the assertion. Okay, and the reason lies in the next property, the cleavage property. I will explain you. But if we talk about the amorphous solid, they have the melting and boiling point in the range. Okay, they have the melting and boiling point in the range. Like if we talk about amorphous solid, they may have melting point between 95 to 100. So they can melt between this temperature completely. Okay. Next property is the cleavage property. That is the most important property that you need to understand. The cleavage property, the third property. Whenever we cut the crystalline solid, they will have the plain and the smooth surface. But if we talk about the amorphous solid, they have the irregular surfaces or the rough surface. So what does it mean? If we talk about the crystalline solid will have the shape like this. All atoms are arranged in a very proper manner like this. This is what crystalline solid. But if we talk about the amorphous solid, they are like this. They don't have the regularity in their arrangement. Okay, like this. So now the reason of having sharp melting point and melting point in the average or the range in the amorphous solid lies here. For example, if I heat this crystal, all particle will get the energy in equal amount. But if I heat this one, all particle will not get the energy in equal amount. Because of that, they will melt at different temperature. They will get the heat in different quantity, so they will melt at different temperature. So this arrangement is of amorphous solid. Okay, and this is crystalline solid. So that's why crystalline solid have the crystalline solids have the sharp melting point. And now what is the cleavage property? If I cut this surface with the knife, okay, for example, if I cut this one with the knife like this, I will get this sharp and plain surface. But if I cut this one, तो किसी की गर्दन कटेगी, किसी के बाल कटेंगे, और कोई किसी तरीके से कट जाएगा, है ना। तो एक रेगुलर सरफेस आपको नहीं मिलेगा अमोर्फस के केस में, लेकिन क्रिस्टलाइन में एकदम क्लीन और नीट एंड क्लीन सरफेस आपको मिलेगा। इसी वजह से ही दे हैव डेफिनेट एंड कैरेक्टरिस्टिक्स एंथैल्पी ऑफ फ्यूजन, बट दे डोंट हैव, अमोर्फस सॉलिड डज नॉट हैव डेफिनेट एंथैल्पी ऑफ फ्यूजन। अब एंथैल्पी ऑफ फ्यूजन क्या है? एंथैल्पी ऑफ फ्यूजन बेसिकली क्या है कि जब हम सॉलिड को लिक्विड में कन्वर्ट करते हैं तो उस टाइम पर जो एंथैल्पी में चेंज आता है, जो हीट में चेंज आता है, दैट इज नोन एज द एंथैल्पी ऑफ फ्यूजन। आई हैव द डेफिनेशन हियर आल्सो, यू कैन अंडरस्टैंड फ्रॉम हियर। लेट मी एक्सप्लेन यू। the change in the enthalpy resulting from providing typically basically heat to a specific quantity of the substance to change its state from solid to liquid at the constant pressure। इस दौरान टेम्परेचर में कोई चेंज नहीं आता है, इसलिए इसे लेटेंट हीट ऑफ फ्यूजन भी कहा जाता है। क्लियर है? तो इट इज द एंथैल्पी चेंज व्हेन द सब्सटेंस चेंजेस इट्स स्टेट फ्रॉम सॉलिड टू लिक्विड। सो दिस इज द थिंग दैट यू नीड टू अंडरस्टैंड रिलेटेड टू द heat of fusion। okay, so now let's come back next important property, that is anisotropy। what does it mean, anisotropy? Anisotropy means, anisotropy is a phenomena in which if we have the solids if we have the solid, the crystalline solids, like if this is the crystalline solid, okay. So if we measure the property, physical properties from different direction, this is the A direction, this is the B direction. If we measure the property from different direction, like physical property like melting point, refractive index, all these kinds of the property, if we measure from different direction, and if we get the different value for the same solid, then that solid will be known as anisotropic. Means it's showing the different values of the physical properties from the different direction, then it will be known as the anisotropic. और अगर amorphous solid की अगर हम बात करें तो amorphous solid में क्या होता है, पार्टिकल तो प्रॉपरली अरेंज होते नहीं है, तो एक क्लस्टर होता है पार्टिकल्स का। तो इसमें क्या होता है, आप किसी भी डायरेक्शन से वैल्यू मेजर कर लो, वैल्यू आपको एक ही मिलेगी, है ना। तो जब किसी भी फिजिकल प्रॉपर्टीज की वैल्यू आप कैलकुलेट कर रहे हो किसी सॉलिड की, और वो डिफरेंट डायरेक्शन से सेम वैल्यू आ रही है, देन इट इज नोन एज आइसोट्रोपिक। और अगर वैल्यू डिफरेंट आ रही है, दैट इज नोन एज एनाइसोट्रोपिक। तो एनाइसोट्रोपिक का केस किस में होगा, क्रिस्टलाइन सॉलिड में होगा। तो आई थिंक यू हैव अंडरस्टूड द कॉन्सेप्ट ऑफ आइसोट्रोपिक एंड एनाइसोट्रोपिक। सो एनाइसोट्रोपिक means having different value from different direction for the same solid, having same value from the different direction for the same solid. So amorphous solids are isotropic in nature, crystalline solids are anisotropic in nature. Next one, what is the nature of these solids? They are true solids, but they are not true solids. Amorphous solids are not true solids. These are also known as supercooled liquid. They have the property to flow. They are also known as pseudo solids because they have the property to flow. Their particles might get flowed down, okay. But the rate of flowing the particle is very slow. It takes years, but still they are not true solids. So who are the true solids? Crystalline solids are the true solids. Order in the arrangement of the constituent particles. If we talk about the order, they have the long range order of the constituent particles. Constituent particles are regularly arranged in a long range, but in the solid state they are not regularly arranged for the long range. They are only short range order. They have only short range order. So these are the differences between the amorphous solid and the crystalline solid. I hope you have understood all these things properly. Now we are going to understand the another kind of the classification, which is based on the nature of the constituent particles. Up to now what we have studied the different types of solids on the behalf of the arrangement of the constituent particles, but now we are going to understand the classification of the crystalline solid itself. Now we are going to classify the crystalline solid itself, okay. So these are the crystalline solid itself. So there are different types of crystalline solid on the behalf of the nature of constituent particles. So first of all we have the molecular solids. So if we talk about the molecular solid, what are the constituent particle in the molecular solids? Obviously molecules, okay, obviously molecules. So we have the non-polar molecular solids, polar molecular solids and hydrogen bonded molecular solids. The constituent particles are molecules. There are different kinds of forces. In non-polar we have dispersion force and London forces, but if we talk about the polar solids, polar molecular solids, there are dipole interaction forces. Dipole interaction forces which have the same dipole interaction means in which both have the dipole, like HCl, okay, they have the delta positive charge, they have the delta negative charge. So this is the dipole molecule, and again we have another dipole molecule, delta H positive delta positive charge, having delta positive charge, this is delta negative charge. So again this is the interaction in between this is the interaction. This interaction is known as the dipole interaction. And if we talk about the hydrogen bonding, you already know hydrogen bonding. So the molecule which have the hydrogen bonding are known as the hydrogen bonded molecular solids, like H2O, okay. So these are the types of attractive forces which lies in the molecular solids. These are the examples. Like if we talk about the non-polar, we have argon, carbon tetrachloride, hydrogen, iodine, carbon dioxide gas. And if we talk about the polar molecular solids, we have the example of sulfur dioxide, HCl. They have the soft nature. They are the insulator of the electricity. all are the insulator of the electricity molecular solids. And if we talk about the melting point, the melting point of the non-polar molecular solid is very low, and other one have the low melting point. So here is the important term is that hydrogen bonding. What do you mean by the hydrogen bonding? This is the thing that most of the students always get confused. Let me explain you the hydrogen bonding. So this is the hydrogen. ये हाइड्रोजन जो है वो सिर्फ कुछ ही लोगों को फोन कर सकता है. किन लोगों को फोन कर सकता है? इन लोगों को फोन कर सकता है. FON, फोन. फोन मीन्स ये इन्हीं के साथ ही हाइड्रोजन बॉन्ड बनाएगा, ठीक है. और हाइड्रोजन पर कैसा चार्ज होगा? डेल्टा पॉजिटिव, और इन पर कैसा चार्ज होगा? डेल्टा नेगेटिव, जब ये मॉलिक्यूल के अंदर होंगे, ठीक है. तो इनके बीच में जो इंटरेक्शन होगी, उस इंटरेक्शन को हम कहते हैं हाइड्रोजन बॉन्डिंग. सो हाइड्रोजन बॉन्डिंग इज द इंटरमोलिकुलर फोर्स. लेट मी शो यू प्रॉपरली. This is HF. Okay. Do you consider is it the hydrogen bond? Is it the hydrogen bond? No, it is not the hydrogen bond. It is what? It is polar covalent bond. It is the polar covalent bond. It is the bond. Hydrogen bonding is not the basically bonding, because in this no sharing of electron is happening, no transferring of electron is happening. Okay, there is simple interaction occurs between the two molecules. Now this is HF. Now we have another HF molecule. Let me show you here. This is HF, another. Okay, delta positive, delta negative. So this one is the one molecule, this one is the another molecule. The force which exists, the interaction which exists in between these two, the hydrogen of one and the fluorine, oxygen or the nitrogen of another molecule, the interaction between them is known as the hydrogen bonding. So this is the hydrogen bonding. Remember this thing. So those molecules which have this bonding are known as the hydrogen bonded molecular solid. Now let's talk about the ionic solids. So what are the constituent particles in ionic solid? Obviously ions. The forces of attraction exist in between them, that is the electrostatic force of attraction. Examples are NaCl, magnesium hydroxide, magnesium oxide, zinc sulfide, calcium fluoride. All these are the example of ionic solids. They are very hard, but they are brittle. Why they are brittle? Why they are brittle? Because the electrostatic force of attraction is short range force. It is a short range force. It exists for a very short range. After that it will not exist, and just because of that they get brittle out. Whenever we hammer them, they get converted into brittle. Okay, so they are brittle in nature. The one and the most important property lies in this is the insulator. The ionic solids are insulator in the solid state, but they are conductor in the molten and in the aqueous state. Why they are conductors in molten and aqueous state? But because whenever we convert them into the molten state or in the aqueous state, the ions become free to move, and that's why they easily conduct the electricity. And if we talk about the melting point, they have the high melting point. Why they have the high melting point? Because of the strong electrostatic force of attraction. Why they are brittle? Because of the short range of the electrostatic force of attraction. Clear up to this? Now let's talk about metallic solids. So in the case of the metallic solid, the positive ions in the sea of the delocalized electron, basically they have the kernel. This is known as the kernel system. Okay, so in this kernel system what happened? This is the nucleus, and we have the free electrons around it, and these free electrons are basically responsible for its electrical conductivity. Okay, and they have the metallic bonding, and just because of this metallic bonding they are very hard and malleable and also ductile in nature. So all these are the properties of metallic solids. They are good conductor of electricity. They are good conductor of electricity in solid as well as in the molten state, and they have very high melting point. So these are the properties which are associated with the metallic solids. Don't forget, all these are the ionic solids. All these are the crystalline solid. All these are the crystalline solids. Molecular solids, ionic solids, or the metallic solids. All these are the crystalline solids. The one And the last important part which is associated with it is covalent or the network solids. The constituent particles are atoms. What kind of bonding exists in between them? The covalent bonding, like silicon oxide, quartz, silicon carbide, carbon, diamond, okay, all these are aluminum nitride, carbon, that is graphite, all these are the examples of covalent solids. They are very hard, but exception with the graphite, which is soft in nature. They are insulator, all these are the insulator, but graphite is the conductor of heat also and electricity also, because of the presence of the free electron, and their melting point is very high. So these are the properties which are associated with the covalent solids. So we have discussed 4 types of crystalline solids on the behalf of the nature of constituent particles: molecular solid, ionic solids, metallic solids, and the covalent solids. Okay, so these are some in-text based questions. You have to attempt all these questions. Classify the following substances on the basis of the nature of the intermolecular forces operating in them. Okay, and another question, that is question number 1.7. A solid A is very hard electrical insulator in solid as well as in the molten state. It is a hard insulator and melts at extremely high temperature. What type of solid is it? So we can conclude that it is a very hard electrical insulator, so we can count it as a carbon. Okay, it can be a carbon because it is very hard and it is insulator in both state, molten as well as in the solid state. And now question number 1.8. Ionic solids conduct electricity in molten state but not in the solid states. We have explained in the solid states the ions are at their position. They are not free to move because of the strong electrostatic force of attraction. When they converted into the molten state, the forces of attraction become very less, and now they are free to move and they become the charge carrier and conduct the electricity in the molten state. What type of solids are electrical conductor, malleables, and ductiles? So these are the solids, metallic solids. Okay, so what is the type? That is metallic solid. So first question you have to attempt by yourself. I will explain this question in the next class also, and if you have any doubt related to this topic which is associated with the part 1 of this chapter, you may ask in the comment box. So this is what we have studied so far. This is related with our chapter solid state part 1. We will come with the second part very soon. Up till then, please watch this video again and again, make your own notes,